Hello everyone. For this video, we will be talking about the project evaluation and review technique and the critical path method, or what we call Pert-Cpm. Pert-Cpm is the quantitative component of project management, and its main output essentially is determining the duration of whatever project you are analyzing. Now, before we continue, we have to define first what a project is. A project is a set of activities that needs to be completed. In this case, each activity has an estimated duration and a list of predecessor or prerequisite activities. Just to give you a visual example, here's the base problem that we will be using. A publisher has a contract with an author to publish a textbook. The activities associated with the production of the textbook are given in this particular table. So as you can see, we do have 10 activities. Remember, the definition of a project is that a project is a set of activities. So we have 10 activities with its duration, and so you have your duration and some predecessor or prerequisite. Okay. Now, I think it is important to note that one of the biggest assumption of Pert-Cpm is that you won't be able to finish the project if there is at least one activity that is not done. So the assumption here is you have to do all of the activities in order for us to be able to say that the project is done. And therefore, we will be able to compute for the complete and entire project duration. Pert-Cpm is part of network models mainly because we will be able to construct a graph for the project. And in this case, there are two ways in which we can construct a graph. One is called the activity on arc method, and the other one is called activity on node method. For our purposes, we will not be discussing activity on arc because creating the graph on an activity on arc method will be much harder. Determining the or drawing the graph using the activity on node will be easier and more understandable. Now, just to give you a quick understanding on what activity on arc means, activity on arc, as the name suggests, put the activities on the arc. Remember, a graph consists of nodes and arcs. In this case, your nodes will not mean technically anything because your activities will be on the arcs. However, however, the easier method, activity on node, puts your activities inside the node. And as you can see in the next slide, this is the graph of the base problem, the book publishing problem in graphical form. Now, let us try to understand how we were able to construct this graph. If you look at the base problem, especially its predecessor, if you look at A, B, C, and D, A, B, C, and D do not have any predecessors. And therefore, in terms of the graph, their main predecessor in quotation mark is what I call the start node. So as you can see, I have a node ST to represent the start and an outbound arc towards A, B, C, and D. Okay? Now, uh, node E has a predecessor composed of activity A and B. And therefore, if you look at E, there are two inbound arcs, one coming from A and the other one coming from B. So, given this, I hope you understand that the act of moving out of a particular activity is the act of doing the activity. So as you can see, a movement outbound from A and a movement outbound of B will lead towards E, because E requires you doing A and you doing B as well. Okay, so I will leave it up to you to be able to check this table, including all the predecessors, so that you will be able to understand and come up with this graph. The numbers in on the arcs are essentially just the duration of the activity. So for example, in this case, activity A, its outbound arc has a duration of 3, which means activity A has a duration of 3, or it will take you 3 weeks to be able to do activity A. Now that we have the graph for the base problem, what is the output of a Pert-Cpm model? There are technically three main outputs of the Pert-Cpm model. First, we shall call it ES, or the earliest start time. Earliest start time is the time at which the event will occur if the preceding activity started as early as possible. I think it's easy to understand what earliest start time is. It's the earliest start time of a particular activity. In the same manner, the second output is called the latest start time. What is the latest start time? It is the time at which it's the last time at which the event can occur without, I think it is important to note that this is the condition for the latest start time, without delaying the completion of the project beyond the earliest time. Okay? And I will discuss this later. Okay. There are technically two more outputs that are related to your earliest start time and latest start time. That's your earliest finish time and the latest finish time. However, essentially, EF is just ES plus the activity duration. And in the same way, LF, or the latest finish time, is the LF plus the activity duration. No? And remember, activity duration is a constant. Therefore, EF and LF are dependent on ES and LS. And that is why I usually do not include EF and LF anymore, because it is easy for us to understand eventually what EF and LF is, as long as you know ES and, sorry, this has to be LS. Okay? And then finally, the last output that we will be able to get from this Pert-Cpm analysis is what we call slack. What is slack? Slack is the amount of discretion in each activity. It is the amount of time that you can technically, how do you say it, procrastinate, no? If you subtract your latest start time and your earliest start time, then that gives you the amount of time or leeway that you have. So for example, let's say LS is 5 and ES is, let's say, 3. So what do these two things mean? That means on the third day, let's say, on the third day you can start already activity A. However, the analysis also tells you you can actually start activity A on day 5. And therefore, if you subtract 5 and 3, that gives you 2 days. So what does this give us? This gives us the amount of leeway, no? Or the amount of time you can slack off. And that is our slack. Now, the solution method that we will be using for Pert-Cpm model is actually the acyclic digraph solution method. However, when we use the acyclic digraph solution method we learned before, we will not be doing the shortest path solution method. Okay? What we need to do is to look for the longest path. Why? Why? In this case, if your main objective really is to determine the project duration, how long the entire project will last, you don't need the shortest path. Why? Because if you get the shortest path, then there will be other activities that have not been done yet. And because we need all activities to be done for us to be able to say that the project is finished, therefore, the shortest path will not give you the project duration. In this case, getting the longest path. The path that will take the longest will tell you how long the project duration is, because given that this is the longest path, then the other paths in the graph will be done as well. And therefore, the longest path will tell you the project duration. And in this case, the longest path is called the critical path. Okay, and I will tell you later why specifically this is called the critical path. Now, I will leave it up to you to be able to use the algorithm for a cyclic digraph. Revise the rule. Instead of looking for the shortest path, look for the longest path and apply that solution algorithm to this network graph. Okay? And I'm hoping that you will be able to apply the solution method or the algorithm correctly and eventually get the same labels. So now, let us try to see where the longest path is in the graph. So according to this table, and we look at the last node, finish, it says we have to go through node J. And if we look at node J, it says we have to go through node I, and then G, and then F, E, A, start. And as you can see, the longest path determined by the algorithm is this. Start to A to E to F to G to I to J, and then finally J to finish. And in this case, we can say that the project duration is equal to 15. Now, what I'd like us to do is to understand what do these labels mean, no, for the activities. So what do I mean by that? What do these 0, 0, 0, 0, 0, 3, 5, 7, 3, 9, 11, and 15 mean, no, for the project? And let's start with the finish, no, with the duration of 15. Okay? So what does this 15 mean? If this came from the longest path algorithm, then that means the duration of the longest path from start to finish is 15 weeks. And therefore, let me propose a different way of defining or understanding 15. Instead of 15 being the duration of the longest path, can't it be that 15 is the earliest time that we can, in quotation mark, start doing finish? I know it's a bit weird, no, to be able to say we are starting to do the finish node, but technically, once you are done with everything, you can technically say you are finished. And what is the earliest time you can say you are finished? At 15 weeks. And that is why the project duration is 15. Now, let's try to understand the duration of the longest path for J, which is 11. Okay? In the same manner, if you look at the graph, the duration of the longest path from start to J, which is start A, E, F, G, I, J, no, will take you 11 weeks. And therefore, the earliest time you can start activity J, and remember, doing activity J is not entering J. Doing activity J is the act of going out. So when you are entering J, you are not yet doing J. You're about to start or do activity J only. And therefore, the earliest time you can do activity J is 11. And what I am saying here is that these numbers, no, are essentially your earliest start time. Or the duration, to be technical about it, the duration of the longest path from start to node I is the earliest start time of node I. Now that were able to determine the earliest start time, the next goal for us is to determine the latest start time. Before we actually determine the latest start time, let us check first again what is the definition of the latest start time. It is the last time at which the event can occur without delaying the completion of the project beyond its earliest time. What does that mean? That means to be able to get the latest start time, the first thing that we have to set is that finish will also be 15 because you cannot delay the project. And therefore, according to the earliest start for finish is 15. Therefore, the latest start should also be 15 for node finish. And if the latest start time of finish is 15 and J requires 4 weeks to be done, therefore, we can technically say J has a latest start of 11. In the same manner, if the latest start time of J is 11, and because C has a duration of 4 weeks, then technically we can say C has a latest start time of 7. I has a latest start time of 9. H has a latest start time of 8. G has a latest start time of 7. F has a latest start time of 5. E has a latest start time of 3. D has a latest start time of 5. B has a latest start time of 1. A has a latest start time of 0. And finally, start has a latest start time of, in this case, 0. Why 0? Because you're actually comparing the different latest start times. One coming from C, so that's a 7 minus 0 is 7. The other one coming from D, 5 minus 0 is 5. B, 1 minus 0 is 1. And finally, A, 0 minus 0. And you get the minimum. So as you can see, the numbers on top of each node represent the latest start time of each node. And that can be summarized in this table. No? So again, we have the labels, and the longest path duration is also the earliest start time. We've determined the latest start time. And once you already have your LS and ES, you can actually subtract LS with ES to be able to get slack. Okay? And I hope you notice that in your Slack, there are a lot of activities with a Slack of 0. Okay, and we can do that here. So again, I'll use red to show Slack. So Slack of finish is 0. Slack of J, so you can look at this. This is your ES and this is your LS. So the slack here is 0. I has a slack of 0. G has a slack of 0. C has a slack of 7. H has a slack of 5. D has a slack of 5. F has a slack of 0. E has a slack of 0. A has a slack of 0. B has a slack of 1. And finally, start has a slack of 0. And I hope it is clear here that activities with a slack of 0, so let me encircle, is actually are actually your activities that compose your longest path. And that is why the longest path is also called the critical path. Why is it called the critical path? Because the critical path is composed of critical activities, and in this case, critical activities are activities that have slack equal to 0. And why are they called critical? Because any delay in these activities will cause a delay in the entire project. Why? Essentially because your slack is 0. You don't have any leeway. You don't have any amount of time that you can slack off.